Hi everybody, I'm Bartosz from Cyrus, and I'm joined today by Bartłomiej Chojnacki, a person with deep understanding and knowledge of acoustics. Bartłomiej, maybe introduce yourself in a few words so that everybody knows your background.
Hello everyone, my name is Bartosz Chojnacki, and I'm the acoustic designer and also the scientist. My main place of work is AGH University of Science and Technology in Krakow, where I work as a scientist, but I also work as an acoustic designer for the brands Soundway Acoustics and Mega Acoustic, one of the biggest Polish acoustic treatment manufacturer. And my main field of the interest is room acoustics, of course, in every part of the knowledge, and also the electroacoustics. However, I have a pretty wide understanding of many basic things in acoustics, so maybe I will be helpful with some explanation of the even quite basic things in sound, which Bartosz wants to know today.
I'm sure of that. I'm quite confident you can help us all. So the idea of the meeting is for us to talk about acoustics, because my impression is it's one of the most commonly neglected elements of a system. I know when you see what pictures people post on social media of their setup, sometimes costing thousands of euros or even more, they rarely pay attention to acoustic implications. So can I start just with a very general question? Why are acoustics important?
So in the beginning, maybe I would be a little, I will say something surprising right now, because I disagree with you that acoustics is neglected. Barely in the past 2, 3, 4 years, I never met a person who says that acoustics is not important. Everyone is admitting how the acoustics is important, that acoustics is the basics. It's like 50% of the good sound, 80% of the good sound, 90, 30.
But
60.
you know, Bartłomiej, if people approach you, they already know it's it's important. But I'm just talking about general feel, audiophiles. So
in general, I disagree that people are neglecting acoustics, but I definitely agree that people will do nothing to achieve good acoustics. It's like people are already aware that they need the acoustics, but still there is a long path from being aware about something to implement it in your own home system, right? So this is what I experience currently. So people know about the acoustics, people know that they need this, but still there is a long way for them to achieve the proper acoustic in the home. Of course, there are a lot of the limitations. Acoustics is not the cable that you can plug and unplug, then return to the shop and try a different one, right? So acoustic is really the one-way ticket. So you need to hire the acoustician in the beginning, plan something, make the measurements, design the proper acoustic treatment, taking care about the aesthetics of the room and many different things. So this is the first thing, is that the acoustic is not so easy as exchanging any other part of the system, right? So this is one of the reasons people do not treat acoustics properly. Let's agree on this point. No neglection, but definitely less attention to taking care about the acoustics. While, of course, I do not need to explain anyone. I hope the acoustics is definitely one of the similar part of the audio path, like the amplifier or the sound source or whatever. So without the proper acoustics, you won't achieve something which we can say in general the good sound, right?
So what are the problems? I mean, you say it's without the proper acoustics you will not hear what was intended. So how would this influence manifest itself? I mean, how can you tell that it's not right?
So this is also the kind of the misunderstanding in acoustics, because people, especially the audiophiles, love to say that they're enhancing something, right? So in acoustics, we try to go in the opposite way let's say, to the basics of the high fidelity. So to achieve not changing anything in the audio path. If you will consider any kind of the recording, whatever source it will be, the file of the CD, so there is a kind of the information. The kind of the information which audio engineer and the artist included into the recording. So divided the material for the left channel, right channel, and it was done in a proper acoustic space. So the sound engineer and the artist and the instruments recorded there make the impression of the sound space, right? But it was made in a proper acoustic space. And if you will, and there is a acoustics in recording, right? Artificial or natural, it does not matter. Still, there is acoustics, which is the part of the art in a recording. And if you will consider this, listening to this in your room, which is not properly treated, you're adding to the recording your own acoustics, which is simply bad, right? Mm-hmm. This is not the proper way of listening. You should listen the material in a shape it was included and, let's say, planned in the recording. You need to have the natural or neutral acoustic space, right?
So what you mentioned the word add. So what can your acoustics add to the recording?
Let's start with the basics of the reverberation, right? So if you have the any kind of the recording, there is the reverberation added by the sound engineer with some plugins or recorded, like, you know, those famous drums recorded on the staircase, right? So there was the reverberation from a staircase, and that's why we consider now this staircase recording as awesome, right? If you will add your room and your reverberation, you are listening like the combination of the reverberation of your room with the recording, right? So it's not anymore the high fidelity, and all the other time and amplitude difference in the recordings. So the room resonances, the additional reflections, then some colorations of the sound, so it's all influence the recording, and then you do not listen the exact recording you wanted to.
Okay, so we mentioned reverberation, yeah, one of the one of the possible problems. What about, for example, imaging? So how would that manifest itself? What is the the best way to achieve the best performance of your system in this respect?
So the imaging and the kind of the spatial impression is kind of the. This is a little tricky because, first of all, as I said, it was treated properly to listen to spatial impression in the recording planned by the artist, right? And you have here, let's say, we are in this industry. You cannot assume that everyone will appreciate like this totally proper space with the proper imaging, right? People like sometimes to fake the impression of the spatial sound, right? So the most important thing for the spatial impression in the imaging is the treating of the so-called first reflection points. So the first order reflections, like this is the same name for the few names for the same phenomenon. So the first order reflections are responsible for the strongest reflections made in a listening point. To simplify this, you can consider this like the first reflection point, and the sound wave approaching from this point is the something which is the same in the direct sound, so the material from the original file, but delayed in the time, right? So like you will receive the two identical sound waves, but the second one approaching from the first reflection point is delayed by a few milliseconds, right? And that's why it's destroying the spatial impression, right? So
your brain will be confused by getting two hues. I mean, the first initial coming from the speaker, and then the reflection. So it's just I'm trying to understand it, in lay terms, so to speak.
Yeah. So considering what the brain will do is even more complicated, because let's assume that will be the two identical sound waves delayed in a few milliseconds interval, but the brain cannot understand the brain will not interpret this as the two separate sounds, but will make them, let's say, the kind of the mix between two signals, right? So it will be and the natural consequence for this will be that the sound image will be shifted somewhere in the space, right? Because there will be two signals, one from direct sound, and let's say the second one from the little different direction, and also delayed in the time, and that's why it's mixing your sound scene.
So how to, because I'm trying to find, you know, practical sort of advice for people watching. So in order to get rid of this effect, you basically have to treat those reflection points. I mean, what I read somewhere, the easiest way to do that would be to place a mirror against the wall and basically from your listening position to see the speaker, right? That would be, do you agree with that?
Yeah, sure, of course. In general, I definitely support some, let's say, home methods to improve the acoustics, because they're correct, right? This is the totally correct method to locate the sound, the first reflection point. And if you will locate it, then you have three options. So to absorb the sound wave there, to diffuse it, or to redirect it somewhere else, right? So
can we briefly explain the difference between the three?
Yeah, so the difference is easy in general, but then the application in a room, it depends of many factors, right? But absorption, so the absorption is very easy. You need to use any kind of the absorbing panel, acoustic foam on the fiberglass or whatever similar. And then it means that you simply attenuate the acoustic energy in this point, so there is no reflection from this point anymore and no mixing information, right?
So basically kill the reflection.
Yeah,
there's no reflection.
Kills the reflection,
obviously, in real life it's not possible, because I mean the lowest frequency probably you won't be able to, but in, you know, just to make it easier to understand, you basically kill the reflection. Yeah,
but we can also precise here. So in the first reflection points and the kind of the reflections, first reflections are the problem in mid and the high frequencies, and in the low frequencies it's usually above something like 150 hertz. So this is not what we call low frequencies usually, right? So even quite thin, like 7 centimeters or 8 centimeters depth panel will absorb enough acoustic energy to say that this reflection point is neglected, right? So this is the absorption, and it's important to point here that it attenuates and you lose acoustic energy. And why it is important? Because sometimes it can make a little tricky impression, the psychoacoustic impression while listening in the room. So if the first reflection points are absorbed, then it means that you lose the energy, and you can feel that that you lose some spatial impression, right? Because
this is what people this is the term I've I found somewhere, is you create a dead sounding room.
Basically. It may be, however, let's go to the basics. So I would say the proper, right? So it usually happens when people are used to some kind of the wide space imaging, and this is what I call little fake impression, right? Because not treated first reflection points are, let's say, of course, it's the fake information. However,
exaggerated.
But the space is bigger. The space is bigger than in the recording. If you will attenuate all the first reflection points, you will increase the clarity, the definition of the sound, but you may lose some space, sounds in with, right?
Sensation of space.
Yeah, and you can lose it. However, it will be a little more precise. But that happens when you use the absorption. If you will use diffusers there, then you will still have the gain in definition and in clarity, but you will probably, so that the diffuser does not absorb the energy. So still it converted from the one strong reflection to the numerous very weak reflections incoming to your ears from different direction, not from the one proper very strong direction, but the mix of them. Of course, we can still call it the kind of the faking, but going further into this discussion, then we will go that the only proper room is like totally attenuated, which is also bad. So let's do not go there, but let's assume that diffusing the first reflection points is better because you do not absorb so much energy and still gain the clarity, gain in the definition, and not so much lose in a spatial impression. Even
okay, let's be practical. So, I mean, without investing a fortune in treatments, just to find out whether you can improve, sound on your own, what can you do? We talked about absorption and we talked about diffusion. Is there anything we can try ourselves before actually, spending a fortune on acoustics?
This is a very complicated thing because
I mean, I'll tell you what I did, and correct me if what I did was correct. I mean, for example, before I invested in diffusers and proper diffusers, I actually located bookcases in those places. So then books acted to some extent. I mean, they absorbed in some way, but also they diffused, because obviously there were differences between how deep the books were, how they were positioned. So and it did improve, in my perception, it did improve the performance.
Of course, the first thing here is to admit that any kind of the furniture or the curtains, draperies, whatever, is usually way better than the plain wall, right? So you said something about not investing the millions, and I'm a definitely big fan of including the budgeting in any kind of the discussion we can make, because we should assume at the beginning that the budget is usually the only limitation for many implementation of everything. So for the electroacoustics and the acoustic, of course, the same way, right? So the method, I really try to avoid general and totally universal statements here. But let's say the general statement here will be to diffuse to attenuate the additional reverberation. But for the first reflection points, use the diffusers or use the absorbers as long as you can without the room over attenuation, and then go to the diffusers because we know some principles in acoustics. They are general and they are correct. We know they are correct, but then, we need to discuss the details. And usually it occurs that those details made the final impact on the decisions you make, right? So there are a lot of the decisions, and budget is one of them, because you need to admit, if you have the bookcase and you can place them properly, made some modifications, it's okay. Bookcases are cheap, especially if you already have them.
Well, depends how many books you have there, but okay. But I was not talking about empty sort of, bookcases.
Yeah. However, the diffusers and diffusing the sound can be 3 to 6 times more expensive than absorbing. So usually in most of the acoustic treatment adaptations, so in the rooms when I'm the designer, I quite rarely use the method to diffuse all the first reflection points, because there is no budget in the project, right? I would love to
but you have to talk about what? The walls? So the side walls, we were talking about the front and the rear walls, plus we are talking about the ceiling and the floor. These are all surfaces which reflect, right? So from each column, you have 6 points of the first reflection, right? So one of each walls, including ceiling and the floor, right? So each of those points should be treated. And in practice, usually you can do this. Let's forget the floor, right? So
Yeah, we can touch the topic of the carpets in front of the listening space, because people usually say that the carpet is the essential, right? And let's say I agree partially, because the carpet, like the thick carpet in front of your listening spot, is the only thing in a practical way you can attenuate the first reflection point in front of you from the floor, right? Okay, I know some people that they bought the additional panels and they're placing it on the floor while listening, and let's admire this. It's beautiful to have so big passion to neglect the practical aspect of the room for this purpose. But yeah, usually it's just the carpet, right? On the ceiling and on the wall, there are way more options. And then there is the decision, right? That's why the acoustic treatment should be planned as overall project, right? Even if it should be divided into the parts because of the budget or of the some construction work in the room, it doesn't matter, because then you need to assume the kind of final effect and then try to achieve those stages one by one, considering the budget, right? So the decision where to diffuse, where to absorb, it's one of those. Also, the budgeting decision.
Can we talk about the money for a moment?
Sure.
Because many people sort of fear that this is going to cost a fortune. So what would you say is the most average budget for a treatment of a room, from to maybe, if there is a sort of a range?
So we should first of all state some the most important things that include the budget of the room acoustic treatment. So first of all is the room size. It's totally clear, right? It's definitely, obviously, more expensive to treat the 40 square meters room than 20 square meters, right? Just because of the simple equation to make some change, like the least significant change in the room parameters, you need more material, then it costs more, right? So this is the first thing, the room size. And the second one is the aesthetics, so the visuals. And this is even more important than the gear in electroacoustics. If you will consider that your room acoustic treatment does not need to be very pretty, then you make a lot of the savings, right? Because even the average room acoustic treatment is quite expensive. And if you will proceed further, something like the solid wood or the custom-made size panel and with the custom colors, that it can really cost a lot, right? So those are the most important variables to need to be considered when considering the money, right? Because considering this, you can make 20 square meters room, both in a budget of 10,000 euros or 2,000 euros, right? Or 50,000 euros. Okay, let's agree that 50,000 euros for the 20 square meters room is something totally, maybe not totally impossible to spend, but definitely something very hard to spend. And there is another point that in electroacoustics, we could consider there's no border, no upper border of the cost you can spend on equipment, while in acoustics, usually it is. So the acoustic panels are not so expensive to fill all the walls, and even with the very expensive panels, it won't kill your budget, considering the people who are spending 100,000-200,000 euros per equipment, right? But even those, the acoustics, of course, also when considering the room, you are never filling all the walls with the panels. Usually, filling up the ceiling with some acoustic absorbing material, the first reflection points on the basics and some bass traps. It's the essential and totally enough, the full acoustic treatment in most of the rooms. And consider the real numbers. Let's be precise here. So treating the room of the size 20 square meters in a proper way with that decent visuals can be the cost of 6 to 8, maybe up to 15,000 euros. Like the 50,000 euros, it's the
that's a lot of money for many people.
Yeah, but this is the budget, like the filled up, right? So you
the full mountain, you have everything,
Yeah, you have everything and everything good looking, right? The 5,000 euros is something when you can do a lot. It's like something that you can have the set of the tuned bass traps, a lot of the proper attenuation panels, but the diffusers in this budget, like the 5,000 euros, you cannot afford, those cheapest one.
Bartłomiej, you mentioned, sorry to stop you there, you mentioned bass traps. This is one of the elements we haven't really discussed. Can you explain what they are for?
So the bass traps are for killing bass. Of course. So one.
But it's it's slightly confusing because some people believe that they want more bass, but we are talking about killing the bass. So
yeah, this is one of the paradox I love to show to people when I'm on the measurements and I'm showing them and trying to explain that yes, we need to attenuate the sound here to achieve the higher, better bass here. Yeah, and that's why, because of the troubles in the bass occurs when we're considering so-called the standing wave phenomenon in the room. It means that in some parts of the room the sound is attenuated, and some parts of the room it's amplified. Right, the bass is very uneven across the room, and that's because of the reflections. And those reflections, the bass reflections, does not work as the mirror method you mentioned a while ago. So it does not go straight forward with the straight line to the wall. So it is described by the wave equation, something a little more advanced in mathematics, right? So, but let's say some of the most basic principles means that the reflection points are in the corners, the room corners, or in the wall, right, next to the wall. So the principle here is to attenuate this reflection to avoid the attenuation of the wave in the middle of the room. So if it's not reflected anymore, then it's not attenuating in a listening point, right? That's why we consider the attenuation at some point as the amplification in a listening spot, right? And you do this with the special absorbing panels. It's very important to understand that in the low frequencies, we never consider diffusion. It is impossible to diffuse the sound in a low frequency range. So we all consider the absorption, right? So we're absorbing the sound in a corner to achieve the better bass response in the listening spot, somewhere around the middle of the room. And we do this with the special acoustic treatment devices called bass traps, right? So the absorbers designed to absorb mainly the low frequencies, and then they are usually tuned for the particular frequency range.
So this is how measurements are, of key importance, because you have to know what you're dealing with, what the problems are.
So I never neglect human ear, and most of the people try to explain that they can also hear the room resonance and try to tune the bass traps or select the bass traps just on the ears, and that's correct. It may happen. Because, for example, I probably would be able to do this. However, I'm a skilled room acoustic engineer, so I made a lot of the measurements. And when I have already this kind of the knowledge, it's like really not a complicated thing to invest in a even basic measuring microphone and make this measurement, right? Because making the measurement is not a very complicated way, because the whole point here and the biggest problem is to interpret it properly, right? So you need to make the measurements, right? And usually, so you can also make some calculations that a lot of the calculators, online calculators for the room modes and the bass traps in the internet.
Okay, can I stop you there again, because you use the term room modes. What is that?
Sorry, this is the same room mode is the same name for the room resonance or the standing wave happening in the room, right? So 3 names of the same phenomenon, and it's always referred to the bass trebles, right? So there are few internet calculators. I never neglect them because they're correct, right? If you have the proper tools, why not to use them, especially if you are not a skilled acoustic engineer and you are searching for the knowledge, right? So they are okay. However, the room calculators, in terms of the modes, usually consider only the rectangular rooms. So it's limited to rectangular room because the analytical solution in the mathematical way is only available for the rectangular room. For any kind of the other
Real
shape,
life, yeah.
then you need the acoustic engineer, really. Made the measurements and made the little more complicated computer models using the finite element method or something else to
So
calculate.
am I right in saying that room modes are basically specific frequencies that are problematic because of the sizes of the room? Like
Yeah,
you
it's
have
strongly connected with the
have peaks or troughs because of because of the fact that sound travels in the room and waves interact with each other, and it's, based on the dimensions, basically you have uneven frequency response in a room because of that, and you can hear it as sometimes missing frequencies. You say, for example, the bass is gone. That may be, or there's too much bass, or ringing. Am I right in saying that?
So to understand and, let's say, visualize this, we may refer to something quite common with the wave phenomenon. So considering the little other type of the waves. So let's say consider the sea waves. And if we will imagine the kind of the surface of the sea, so on the sea you have the waves, and there is the peak of the wave and the valley of the wave, so the lowest point. And if you consider the same, that also the sound is the kind of the wave, which is, we know it, of course. So closing the room, you also meet the kind of the peaks and the dips in the frequency response, but let's say the pressure around the room, right? So no liquid there, no water, but the sound pressure.
Sound pressure.
So it can be on the top and on the dip. However, the top and the dip in the terms of the pressure is the same. But the problem is that between the top and the dip, there is a 0 point, which means that you hear nothing, right? Because it's not traveling across the room, and that's why we call it a standing wave, because it does not move like the normal sound, but it stops because of the reflection connected with the geometry of the room, with the one of the sizes. It reflects and attenuate all the times in the same point in the room. That's why it's a standing wave, and it can work in both ways, in attenuation or the amplification of the given frequency across the frequency spectrum.
But as we're talking about 3 dimensions in the room, we've got height, the length, and the width. Then we have at least 3 problems, right? Or can we have more than 3 problems?
So the room modes are dispersed between. Usually they are connected. So that can be both connected with the only 1 dimension, 2 dimensions, or all 3 of them, right? Usually when we are considering the modes, we give them the numbers, like the first mode, the second mode, or we are defining the which kind of the mode it is for the particular dimension. Everyone can make this experiment on your own using just a simply frequency generator. There are a lot of them in the internet, and try, because, for example, if we consider the so-called mode 1, 0, 0, 3 numbers, right? So it's connected only with 1 dimension, which will be like the length of the room. And in this case, it means that the sound pressure changes only with this 1 dimension. So like moving up and down in a Z dimension, right? You will not hear the difference, right? It is this constant pressure across this 1 dimension. When we are considering the higher room modes, they can be connected with 2 dimensions at the same time, or 3 dimensions at the same time. But we should also point here that usually those are the higher modes, which usually are not the problem in a room. So usually you have the troubles with the 2, 3, 4.
And how do you handle that? How can you get rid of that or improve the performance in this respect?
So the bass traps, this is the only thing here. And it's also important to point that in a bigger room, usually you have smaller problems with the room modes. Because there are some basic acoustic principles. When you have a lot of the modes close to each other, then it's trying to blur the effect of the single mode, so the single excitation and the big difference in the space of the room, right? But it happens in the higher frequencies. And there is also something which is called the Bonello criteria, which describe the border when you can consider that there is enough room modes in a given frequency range to achieve the proper bass response.
So
right?
is it about the perfect room dimensions? More or less what you said? Or because sometimes...
Yeah. So the Bonello criteria is one of the criteria we use to rate the room dimension or the room proper room dimensions, either proper or not. The best, so I was investigating a lot of the best designs, and once again we cannot say like this one is correct and build only this one. So it still depends on the room size available, right? The main principle here, the bigger room, the less troubles with the bass you will have. But let's consider something I said a while ago. Bigger room, the more money you need to spend to have the proper treatment, right? So everything is connected here. I would say of course, the very small rooms like 10 or 15 square meters are quite too small to achieve the proper bass response under something like 50, 60 hertz, right? To have the proper bass response in the 40 and hertz and upper, you usually need to have something like 25, 30 square meters, right? And I could also define like the biggest room, in my opinion, affordable, and like let's say also let's precise that we're talking about the dedicated room only for listening to music, not like the open wide living room. So the biggest I would recommend is something like 40 to 50 square meters. It is big enough to achieve the proper bass response quite early, like 30 or 40 hertz, and it's not too big to like kill your budget. However, still the 40, 50 square meters of the room is something like the dream for most of us.
Yeah, I mean, mine is like 15 square meters. I mean, you saw it. So what would you say is the minimum size of the room to actually achieve acoustics, proper acoustics, without spending a fortune?
You know, I'm the scientist, so I would never say there is a minimum to achieve the proper acoustics, right? I would translate this question to something that this is my approach to acoustic design. You should always try to achieve the best acoustics in the conditions you have. So I would say you can have very good acoustics even in 10 or 12 square meters, right? But you need to just admit it and like accept that you won't hear the lowest bass like 50, 60 hertz in 10 square meters. It's simply impossible, right? And if then you can say that, but what is the dimension that to achieve? Okay, so we should then define that the proper acoustic impression and the proper acoustics is where you can try to listen to full audible frequency spectrum, right? So 20 hertz to 20 kilohertz. Then if we will say this is the condition here, so you will need to have the 40 square meters or 50 square meters of the room, right?
Otherwise, there'll always be compromises.
Yeah, this will, of course, when considering 20 hertz, right? Let's search for the material where we have the 20 hertz so present, right? So usually, not many people need 20 hertz. So if we will go a little more practical again, so 30, right? 30 hertz and upper frequencies, then something like 25 to 30 square meters is a very good size for the listening room. It's affordable and let's say bass efficient.
And can we also talk about, because one of the topics, which many people ask about is what are common mistakes people do when setting up the systems? And because I would like our sort of viewers to, benefit from this call. So what are the most common mistakes you've seen people do?
So at the beginning, I would say taking the acoustic treatment process without the basic knowledge, or which is also common and even worse, taking this topic with the bad knowledge, or like the few not really verified articles read in the internet or repeated sentences by the people. Like the acoustic foam is not working, use the carpet, use the curtains, or place the blanket on your TV or something like this, right? So lack of the knowledge is essential here. Of course, I have some lectures around the internet how to make acoustics. There are a lot of the books, but of course no one can get a PhD in acoustics before treating your own room, right? So of course the kind of the compromise is here to hire the acoustician, right? But it's also the kind of the expensive way. So first of all, get some knowledge, try to discuss with people, and it's quite rare situation that, like in any kind of the thread on the Facebook page on the internet forum, like everyone is wrong. This is quite rare. So if you will read some sentences of the people, usually everyone is saying something else. So you can make the average, use your own brain, and then you will have the basic knowledge how to do this. Because the knowledge, lack of the knowledge is the biggest mistake here. But let's try to leave the philosophy here and go to something practical.
Tangible, yeah.
Yeah, so the one of the most common mistake here is using too much very thin absorbing materials. This is very common because the thin acoustic material absorbs only mid and high frequencies, or only high frequencies. And using this, you will even do not solve the problem of the first reflection. You won't solve it properly. You will solve just half of the problem, and using too much of those will over attenuate the room. The over attenuation is one of the worst thing you can apply to your room, because then you will feel a lot of the energy in the low frequency range and no energy in the high frequency range. It makes very, very terrible psychoacoustic impression. So this is the first thing. Then people usually try to use the flowers, the flower pots, the books. Okay, the problem with the non-professional acoustic treatment devices is that we never know how exactly they work on the room. And then it makes the problem that people try to assume themselves that, okay, I have a lot of flowers, the books, and acoustic is solved. So it usually do not work properly in this way, right? So it's never solved. It can help, like the draperies of the curtains usually help a lot, reducing the reverberation or something like this. And we can assume that with some luck and a lot of the trials, you can achieve the proper acoustic room in terms of the reverberation with the curtains, flower pots, and draperies. But first of all, add some bass traps. Like the bass traps do not occur in a natural way. You cannot replace the bass traps with the furniture or the flower pots. You need to have the professional bass traps. So sometimes adding the the normal things like the furniture to the room and some bass traps, you can achieve pretty nice acoustic space. But then also it makes the mistake people do, so overrating their acoustics. Like my acoustic is good because I have all of the furniture and a lot of the flower pots, bookings, whatever, and my acoustic is good. So if it's so,
but then having furniture in the room is better than having no furniture at all. We see a lot of pictures taken, in empty rooms. So basically, I think, a room with furniture in it is better acoustically than a room without anything in it, right?
once again we hit the wall when it's difficult to simplify those things, right? I would agree that totally empty room is worse than the furnished one, right? But also too much furniture and the elements inside. First of all, you take the place that probably should be taken, but some acoustic treatment. For example, the first reflection points. I do not. Let's point again that it's not necessary to place the acoustic treatment around the whole wall, whatever the wall we consider, right? I'm just talking about the points, the first reflection points. If there is a furniture, you cannot use it for the professional room acoustic treatment, right? But also if there are too many elements, so it's the most difficult thing to remove something, right? Usually when you come to the over attenuated room and you see that there is too low reverberation in a high frequency range, there's no other choice than to remove something. This is one of the things like very common to me, because I was treating a while ago the room for the guy in your home city in Poznań, where I met a lot of the thin acoustic thin but good quality, but very thin, like 2 centimeters acoustic absorbing panels. And until this guy totally removed like 20 square meters of this from the room, we couldn't do anything, right? So this all happened to the bad treatment and too big overestimation of my acoustic is good.
Yeah. I've seen that also with some retailers, strangely enough, rugs on the walls. And again, this, as you said, this just attenuates certain frequencies, meaning the rest is amplified, basically, by comparison.
So the problem is this is all connected to each other, right? So we can never say that if you are attenuating one frequency range, this is the kind of connected with the psychoacoustic impression. If we consider like everything, I will try to do this in this way. So like the plane curve of all frequencies in the same size, right? So attenuating one range will mean something similar to boosting the second one.
Yes.
Right? So that's why if you will add some carpet, attenuate the high frequency range, then you can feel...
By comparison, the bass will be stronger.
Yeah, exactly. It can be, of course, moved in increasing the power of the amplifier or whatever, but in opposite also work in this way. So attenuating the bass will also put on a higher plane the mid and the highs, right? So it's all connected. That's why it's also important you start to talk about the common mistakes people do. This is also kind of the mistake that people are taking care about only the first reflection points, the reverberation, mid and the high frequencies, and do nothing with the bass. And then you approach the room and it occurs like there's only the bass. So also it is important to make the acoustic treatment comprehensive, right? It should consider all the components, so the lows, mid, and highs, and usually some diffusers, some ceiling panels, whatever. So like you have, in the best case, you should have something on each reflection point and from each group of the panels, from the bass traps, absorbers, and diffusers. You never use only bass traps, never use only diffusers, which is also a very common misunderstanding. People think that the diffusers are like the treatment of the whole evil of the room acoustics. It is not, because one of the basic principles here, and this is what I explained in the beginning. So, I told you some basics, and now we are going into the details. And in the basics, the diffusers are the treatment for everything evil in the room acoustics, because they have no cones, right? Only pros. However, if you will consider the phenomenon that in the high reverberation in the room, using the diffusers will make them quite low effective, right? So if you have the bigger reverberation, then you can even do not hear the influence of your diffusers, right? So first of all, you need to make the reverberation proper, then use the diffusers. You never should use the diffusers, only the diffusers. I will place a lot of the diffusers, and then my acoustic is fixed,
sorted.
right? It does not work in that way.
Do you have any recommendation for the listening position, for example, or the location of the speakers? Are there any rules we can implement here?
Yeah, of course, there are a lot of the basic rules, but usually people know them. So the most basic rules. So do not place the speakers in the corner. The room listening position right under the wall is also a bad thing. The same with the speakers, right in front of the wall. Even 20 or 30 centimeters is better, right? Just do not place it directly in front of the wall. And also there are something like the distance of 80 centimeters to 150 centimeters is usually bad for the most of the speakers, because it increases significantly so-called sidewall reflection, SBIR effect, right? But that's all. That's all regarding the general things in placing the loudspeakers. And
does a type of a speaker play any role? Whether it's vented, whether it's an open baffle speaker, electrostatic speaker, does it matter?
So for the loudspeakers placement, usually it does not. Because this is also kind of the very common misunderstanding for people, that you should not use the rear bass reflex speaker right next to the wall. It doesn't work in this way. It does not matter, because until you will, cover it with the wall or with something else, the bass reflex port, it will work properly, right? However, there are a lot of the difference in room treatment if we will consider different speaker construction, especially if you will consider the open baffle or dipole type of the speakers, or going farther, the omnidirectional sound sources, right? So for those kind of the loudspeaker, then this is kind of important. They require different approach for the especially for first reflection point treatment, right? If you will have the kind of the dipole loudspeaker, then it is even more important, for example, to diffuse the sound on the on the front wall. Or for I had the pleasure 2 or 3 times to work with the omnidirectional sound sources, right? So the MBL speakers, for example, and in those kind of the speakers, it is very important to diffuse the sound on the first reflection points, because otherwise you will kill the character of those speakers. If someone selected this kind of a sound source, then I agree, it's someone else's opinion, right? It's not my speaker, and I need to try to achieve something unachievable in my kind of my industry, right? So I need to try to understand what kind of the acoustics will be appreciated by this guy. And if I already see the open baffle speakers, the omnidirectional speakers, usually it means that people like a lot of the space. Even if we consider it a little fake or overwhelmed, like overboosted in the room, I'm not someone to judge, so I would not
it's personal.
enter the room.
It's personal,
You are listening to bad equipment, you need to change it. I accept it, and then I need to help this guy to achieve even better listening conditions, considering what he likes or she, right?
Okay, one question that came up. There are some stories of available on the internet, or actually manuals how to build absorbers made of rock wool. They are pretty easy to make. Do you think this is a solution in some circumstances for people? Is it helpful?
So when we consider the absorbers, like the basic fiberglass or foam absorber is It's easy to make. It's not really no rocket science there. You just need to buy some fiberglass from the decent market, and then cover it with some fabrics to avoid the dust approaching your lungs, because it's dangerous for your health. However, all you need to take care is the fabric, the textile you will use to cover the fiberglass will be available for air to travel across, right? So it needs to be, you can, for example, even take the part of the textile and try to breathe
through it.
If you will test in this way and you will be able to breathe, that means it does not stop the sound wave, and you can use it for the fiberglass protection. So take the fiberglass, cover it with the fabrics, and you will have the decent fiberglass, so the broadband frequency range absorber. But that's usually I summarize this. That's all you can do on your own. And making the diffuser, if you will consider that you have some carpenter skills and some tools, and you will find some calculators in the internet how to do this. Okay, you can do this. You can make that decent diffuser, but usually the professional component will do this better. The diffusers need to be stiff, need to be hard lacquered, so to reflect the sound, and the precision there is quite important. And of course, when you will consider the aesthetic part, usually people at home, even with some carpenter skills, cannot make the diffusers looking so good as the professional company can do this, right? So I definitely, once again, I'm up to support people building the decent absorbers at home, right? Because covering the fiberglass with the textile is not something easy, and everyone can do this, right? The cheapest way to treat. And if you will ask me how to do this like zero cost, right? Go to the market, buy some fiberglass, cover it with the textile, place it in the 4 first reflection points, and your acoustics will be better. But this is all I can promise. It can be better, and I cannot promise it will be good. To make it good, you need to, first of all, start with the knowledge and the measurements, or the acoustician, and make the proper treatment in the 3 ways. So the bass traps, absorbers, and diffusers, as I said a while ago. So building diffusers also even more complicated. And one last thing here, I'm definitely, I'm almost sure that like building the bass traps at home is usually impossible, especially the tuned bass traps, because you cannot even verify its performance. You never know if it works in the frequency you made. Of course, you can make the exact room measurements, so try to test it, and if it won't work, it's okay. But then I go to the topic we already discussed. So people tend to little overrate their acoustics, and then applies some psychological things. So I built the bass traps on my own, I made my own room acoustic treatment, it needs to sound properly.
You expect it to sound better.
You expect it to, it's like kind
and
of
then
placebo effect.
Yeah,
which is not always true.
Okay, thank you very much for the time, and I hope to speak to you again about some other topics.
Yeah, thank you very much. It was my pleasure.
With acoustics. Thank you very much. Thank you very much.